Tēnā koutou, tēnā koutou, tēnā koutou katoa. Ngā mihi nuhi ki a koutou katoa. Hello everybody and a warm welcome to everyone. I'm Gerard Rowe, I'm the Deputy Dean Academic in the Faculty of Engineering, and it's my great pleasure to welcome you to the University of Auckland to the Engineering Futures Evening presentation. What we're going to do this evening is we'll spend somewhere between an hour and maybe an hour and 10 minutes in this room. And then if you want to stay on afterwards, a little bit along the corridor in the main foyer, a number of my colleagues will be available who can talk to you about the 9 specialisations that we have in engineering. There'll also be experts from our student centre available to talk about any admissions queries that you may have as well. So what we're going to do this evening is, first of all, we'll talk about what engineering is, because not everyone in the audience might fully appreciate what the role of a professional engineer is. We'll have a look at what happens if you choose to study here. What will you be doing in your first year? How does it relate to the sorts of things you're doing in your final year at high school? And then we'll look at how we select students at the end of the first year into the 9 specialisations that we offer at the University of Auckland. We'll talk a little bit about admission requirements, and in particular the 3 most common routes into engineering: NCEA, Cambridge and International Baccalaureate. And we'll also have a look at an alternative pathway into engineering via the Bachelor of Science. We'll talk about the option that's known as a conjoint degree, where you actually do 2 degrees together, finishing both of them in a combined time that would be slightly less than if you did them actually serially, one after the other. We'll also have a look at some of the real-world projects that our students get involved in throughout the 4 years they spend with us. And we'll have a look at exchange opportunities. That's where you can take a semester off from the University of Auckland and you can go overseas, study there and cross-credit that back to your degree. Then about that point in the presentation, I'm going to hand over to one of our student presenters this evening to tell you a bit about student life at the University of Auckland. I'll come back and tell you a bit about the sort of academic support that we provide, because we provide a lot more support than perhaps people suspect we actually do. Then another of our student presenters is going to tell us about the Tuakana program, and a further presenter is going to tell us about the Women in Engineering Network. And then I'll finish off the presentation talking about scholarships, career opportunities, and the accommodation options that are available at the University of Auckland. So roughly an hour to an hour and 10 minutes in this particular room. Since none of you are familiar with this particular environment, there's a little bit of housekeeping we have to do first of all. It's pretty unlikely that anything's going to go wrong, but if it does, there'll be some very audible alarms will sound. Those of you who are in the front half of the room, exit on either my right or my left. Those of you who are in the rear of the room, the exits are through the back door. If you need to use the bathrooms, through the back door and across the foyer. And this would be a great opportunity to check that your cell phone's on silent as well. So what I'm going to do now is I'm going to play a video, first of all, to tell you a little bit about what it is the professional engineers do, and also what each of the 9 specialisations that we offer here, what they actually involve, what careers would be available to you.
From the moment you get out of bed in the morning, your life is influenced by engineering. As the toast pops out of the toaster, as you take milk from the fridge, get a lift to school and play a game on your phone during the journey. None of these activities would be possible without the help of an engineer.
Engineers love to solve problems. It's what inspires us to design and create new things. And the tools we use to do this are maths and science.
Engineers are creative and imaginative. Problems don't scare us, they inspire us to invent new solutions. Engineering is exciting, with a wide range of specialities to suit your interests. Mechanical and mechatronics engineers use the principles of physics to create machines that improve people's everyday lives. From cars, to food blenders, to jet-propelled backpacks, mechanical engineers are at the heart of the design process. Chemical and materials engineers use an understanding of chemical, physical, and biological transformations to find solutions for consumers and for industry. They find new ways of converting raw materials into useful products, like milk into baby milk powder, natural gas into heating, and crude oil into fuel, while making sure we don't damage ourselves or the environment. Bridges, roads, high-rise buildings and dams are all planned, designed and built by civil and environmental engineers. They work hard to make sure the things that we build follow sustainable principles and are strong enough to withstand wind, rain and even earthquakes. Electrical and electronic engineers are experts in electricity and how to use and control it. Electricity keeps cities and towns running, hospitals functioning and business humming. Computer systems engineers design computers and software that put the intelligence into everyday items, like cars and fridges, making all of our lives easier. Software engineers design the code to make all sorts of devices work, phone apps, video games, and computer programs. Engineering scientists use advanced mathematics to solve real-world engineering, business, and industrial problems. And biomedical engineers develop solutions for healthcare, improving patient care and outcomes.
Here at the University of Auckland, the Faculty of Engineering has a range of fantastic programs that will give you all the skills you need to become an engineer and really make a difference.
We'll teach you how to problem solve, how to think critically, how to work in teams, and by asking the right questions, you too can create new and innovative solutions to engineering challenges.
I would definitely recommend studying engineering here at Auckland. They give you so much support, so you've always got help when you need it. There are so many specialisations on offer, and you meet inspiring people every single day.
Once you leave university, there's a huge number of jobs available to our graduates. With a degree in engineering, your career can take you anywhere in the world.
If I was to look across all my peers in my year group from engineering, they're doing some amazing things. Everyone's found a job they want to do and something they're passionate about, and it's taken them to all these cool opportunities within the country and across the world.
Engineers find solutions to both old and new problems as the world moves rapidly towards a more technically advanced society. Study engineering and make the unimaginable happen.
Engineering is a profession that's constantly evolving. 20 years ago, who would have thought that our students would be designing and using drones such as Theo on the slide behind me? What do engineers do? Well, essentially we're problem solvers, we're innovators, and above all we make a difference to people's lives. So we solve problems such as the yacht design and optimization problem that Rebecca's working on the slide behind. Problems may be to do with structural engineering, such as the beam that Joseph is working on. They're real-world problems. The stakeholders have diverse and often conflicting requirements, so there's not a single right solution. So the first step in the problem solving is actually to analyse the problem, to identify what the requirements are of the stakeholders, to design a range of possible solutions, work out which is the best compromise given the range of expectations of those stakeholders, and implement that. And the implementation might actually involve working out how you're going to dismantle that building in 50 or 100 years' time when it's reached the end of its design life. So engineers are problem solvers. But what we do also makes a huge difference to people's lives, such as the medical devices that Andrew McDade, one of my colleagues, works on and is displayed in the slide behind me. So engineers are problem solvers, we make a huge difference to people's lives, and we're innovators. We design products that have never existed before, but we also take everyday products and we reimagine them and we use them and alter them in ways that were never envisaged when they were first designed. For instance, the health robot that's actually in the background that Rosa's working on. Who would have thought we'd be doing that 15 years ago? The sorts of innovations that have occurred in my lifetime, I can remember as a postgraduate student at this university standing in our laboratory and opening up the box that contained the first personal computer we'd ever acquired. I can remember working on the designs of the first cell phone systems early in my career as an academic staff member here. I can remember as a small child growing up in rural New Zealand being so envious of my best friend who was actually flying to Australia. It felt to me like he was going to Mars. These days, the transportation systems that engineers have developed, we would think nothing of a journey like that. So engineers are problem solvers. We're innovators, but above all, what we do makes a huge difference to people's lives. Engineering is a secure career, it's a well-paid career, but the best part of it is at the end of the day, you can go home and you know you've done something that makes the world a better place. So suppose you do decide to study with us. The degree is a 4-year degree. It is taught entirely on this city campus. So we have multiple campuses at the University of Auckland. We're slowly extracting ourselves from the Tamaki campus, but we have a campus for education in Epsom. We've got a research and innovation campus at Newmarket. We've got the health campus at Grafton and the Central City campus. All of the teaching for engineering will be done on this site. As you may have noticed as you drove in, if you parked in the ONG Glen car park, you would have seen at the back of the engineering building, we're actually building a new block. We've knocked down the back 2 blocks, if you're familiar with the old layout of engineering, and by 2020, when the students here are in their 2nd year, all of engineering will come back onto that site in a purpose-built building designed to include much more active, flexible, student-focused learning than is possible in a traditional lecture theatre such as the one we're sitting in tonight. Your lecturing will be done mostly on this campus, in fact in this theatre. We use this particular room and an identical room that's 1 floor up for most of our Part 1 lecturing. So if you studied with us, you'll study 8 courses in the first year. We teach on a semestral basis, so there's 4 courses in the first half of the year with final exams in late June, and then there's another 4 courses in the second semester with final exams late June, early November. Roughly the first semester is the bit on the left, and roughly the second semester is the piece on the right. The only flexibility is in the top line, when the general education course can be taken in either semester, and the engineering design course can be taken in either semester. But thereafter, that diagram mirrors the first and second semester layouts. So if we look first of all at general education, this is a requirement of all University of Auckland degrees. It requires you to have a broadening experience where you take a subject that is not engineering and it's not a closely related science subject, but it gives you a broadened outlook. So this could be history, theology, philosophy, a language, something that appeals to you. You choose it from a couple of schedules that we actually make available to you for anyone who's studying engineering. The next course down, mathematical modelling, builds on the maths courses that you're all studying in high school. However, notice it's modelling. It's not pure maths, but we're using maths to model real physical problems. The next course down, engineering mechanics, builds on the mechanics that you're all studying in physics. It's got 2 halves, a statics half, which is taught by our mechanical engineering department, and a statics part that's taught by our civil engineering department, and a dynamics part that's taught by mechanical engineering. The next course down is unusual. You won't find many engineering faculties that have this course. It's engineering biology and chemistry. It assumes no prior background. So you don't have to have been studying biology in year 13, nor do you have to be studying chemistry. If you are, you'll find this course correspondingly easier. The reason we include it is that we believe there's going to be a convergence between the physical and the natural sciences, and by the time the young people here are mid-career, we want to put you in a position where you can leverage that convergence. So we want to be sure that you all have some understandings of biology and chemistry. One of the differentiating aspects of engineering versus perhaps a science degree is that in engineering we teach you how to design new products, to create things and systems that have never existed before. So throughout the 4 years of your engineering degree, you'll be introduced to the design process, starting with conceptual design in the first year and also introducing you to working effectively in groups as well. The materials science paper introduces you to how we process raw materials and convert them into a form where we can actually make useful products out of them. And again, this is a course that assumes no background. It doesn't assume that you've done chemistry before. In fact, if anything, it probably draws a little more on physics than it does on chemistry. The electrical and digital systems course draws on the electricity sections of the physics courses that you're studying, so it introduces you to circuit theory, some analog and digital electronics, and I'm one of the lecturers in that particular course. And then the final course, Engineering Computation and Software Development, introduces you to good programming practice. It's got two halves. The first half, which is taught by engineering, teaches you programming using MATLAB. The second half, which is taught by computer science, introduces you to programming using the language C. And a little later, when we get toward the end of the presentation, I'll tell you about some other opportunities that are coming up where you could visit the University of Auckland campus to find out more about engineering. One of those is an upcoming Courses and Careers Day, and two of the courses that you see behind will be running workshops on that day. The electrical engineering course will be running a workshop on controlling an electric vehicle. And the course that's highlighted at the moment, EngGen 131, the programming course, will be running a workshop on coding for beginners. So if they have some appeal, please come along to our Courses and Careers Day, which is Saturday the 25th of August. So in part one, as well as the academic material, we also want to help you make a decision as to which type of engineering you would like to study. Based on past practice, a number of you will already know what discipline, what speciality you want to study, but many won't. And I suggest to you keep an open mind, because you might actually come in thinking you want to be one type of engineer and then find there are opportunities that you never suspected. So during part one, we introduce you to all of the options, and that will include bringing in speakers from industry to talk to you about what different careers are actually available to you. And at the end of part one, we select the students into the 9 specialisations that are actually available. So those 9 specialisations are on this slide here. You'll see that they're slightly different sizes, and the capacity that's available in each of those specialisations is controlled by the job opportunities that are available in New Zealand, and also by the resources, staffing and lab resources that we currently have available. But they do change over time in response to changing employment possibilities and changing student demand. Now, if you are absolutely certain you want to get into one of those specialisations and you're thinking, how can I ensure that? What do I need to do? You need to get the highest grades you can in part one. But as a general rule, a B+ average in part one will get you into your specialisation of choice. So that's roughly the sort of level you actually need to ensure you'll get into your chosen specialisation. So if we now turn to the entry requirements, the slide I have in the background is actually a picture taken a month or so ago of our new building. It's advanced since that point, but we'll start occupying it late in 2019, and by 2020 we'll be fully into that building. That building will contain a number of flexible teaching options, so we're starting to move away from, as much as we can, from traditional lecturing, such as I'm doing at the moment, to more student-centred active learning, and the facilities that we're putting into that building will allow us to do that. Now, one of the things we try to do here is to make sure your transition from high school to university is as successful as we can arrange. So we mine all of the data we have available to us to identify what makes for a successful outcome and the converse, what is likely to lead to academic difficulties. And one thing that we've identified, which applies to all of the programs at the University of Auckland, is that everyone studying here needs a sufficient level of academic English. So there's a university-wide requirement that's known as the Academic English Language Requirement. You'll see the various ways that you can actually meet it on the slide behind. If you meet that, you don't need to take any other action. If you don't, because of your prior study at high school, meet this requirement, then it doesn't stop you getting into engineering or indeed any of the other possibilities here at the university. But what we do is we actually restrict the range of general education courses you can take in your first year. And we force you to take a general education course which will bolster your academic English, because we know that if that's not good enough, it will likely lead to an unsuccessful outcome. And then every student who enrolls in every single program here We get you to do a diagnostic English language needs assessment. That's the bottom line on this particular slide. If your academic English is good, that takes about 20 minutes, and it's something you do in orientation week before lectures start. If that isn't successful, then we get you to do a slightly longer 2-hour test, and if that doesn't work, then there's some online work we get you to do again to bolster your academic English. And if you come into engineering, you'll find that this is captured in your program via a course you'll find in the degree descriptor called EngGen 199. It's the course that actually picks up that you've got satisfactory academic English. If we turn then to the various entry routes, time doesn't permit me to go through everything, so we're just going to look at 3: NCEA, Cambridge and International Baccalaureate, but we have advisors from our Student Centre here tonight that you can talk with later if you're coming in via a different route and you're unsure whether you meet our entry requirements. There's a common pattern on the next 3 slides, and you'll see down the bottom of each slide we identify the guaranteed entry score for the Bachelor of Engineering Honours degree, and then the slightly higher guaranteed entry score for a conjoint degree between engineering and some other subject. A lot of people misunderstand the guaranteed entry score. We set that really high so that we're not overwhelmed. The way we're funded is that the government, the taxpayer, pays for the running of most of the running of the university. The student fee pays maybe a quarter to a third of the cost, but the rest is paid for by the taxpayer. So the government can't simply permit open entry. They contract with the university to fund a certain number of places, and we have to be careful that we don't go well over that limit. So we set the guaranteed entry quite high so that we can control our limit, and then we come under that score depending on how much capacity we actually have. But in any year, we would expect to go well under that. The only time we haven't is in the period immediately following the Christchurch earthquake, when people from the rest of New Zealand were uncomfortable going to Christchurch until they were sure things had settled down. They now have. The University of Canterbury, particularly the engineering faculty, is back to its pre-quake numbers, and the pressure is eased on us. So if you know you're not quite going to get to the guaranteed entry score, don't be put off applying, because we will definitely actually go under those scores. So when we mine the data and we look at what makes for a successful outcome, we've found over many years that you do need a good understanding of physics and you do need a good understanding of mathematics. And the way we ensure that is slightly different for each of the entry qualifications. In the case of NCEA, we insist that you have at least passed the 16 external credits at level 3 physics and the 17 external credits in calculus. And the reason is that electricity, waves and mechanics, which are the externals in physics, are key gatekeeper courses that you need to understand for a successful transition into part 1. And similarly in calculus, differentiation, integration and complex numbers, which are the 3 externals, are again key gatekeeper courses and subjects that you do need to understand for a successful outcome. And then in calculating your rank score, we look at the best 80 credits and use that to calculate the score. We do something similarly with Cambridge. Again, the guaranteed entry scores for the BE Honours and the conjoint are down the bottom. We look at your rank score accumulated over 6 subjects, as the slide suggests, and we would normally require maths and physics to full A level, but on a case-by-case basis, we sometimes take people in with AS maths or AS physics, provided they've achieved very well in that maths or physics course and provided that their rank score is sufficiently high. And we do something similar for the International Baccalaureate. We require the full diploma. We would prefer maths and physics to the higher level, but we realise that there are some difficulties with this qualification, that if a school is trying to set their curriculum so that their students can both meet requirements for engineering but also meet requirements for science or for medicine, it's quite difficult to offer the full range of science subjects in the International Baccalaureate. And there's also a number of maths teachers who feel that higher level maths in IB is actually pitched too high, that it's pitched more like first year university rather than year 13. So for that reason, again, on a case-by-case basis, we will sometimes admit people with either a standard level maths or standard level physics, provided they achieve well in both and provided that their rank score is actually sufficiently high. Now, suppose you're passionate about engineering, but you didn't manage to get a high enough score to actually get in. Don't despair. It's still possible. What we suggest you do is actually enrol in a BSc and look carefully at these instructions that are given both on the Faculty of Science website and also on the Faculty of Engineering website, where we've crafted an alternative pathway, and we hold 30 places in Part 1 for semester 2 available for students via this pathway. So it's competitive. You have to get the best 30 grades. However, it is an option available to you, but we've set the pathway up so that if you decide after a semester in science, actually it's fantastic and you'd rather stay, and many do, then it's set up so that you're positioned well to go into your chosen major in science. Or if you decide, no, I definitely want to do engineering, then we can mostly cross-credit the entire first semester. Depends a little bit on what subjects you choose. So sometimes, as you'll see in the very bottom bullet point on that slide, you might have to do one summer school course to catch up, depending on what you did in that alternative pathway program. Now, another option that you might not be aware of is that you can at the University of Auckland do a conjoint degree. It's not available in all universities in New Zealand, but it is available here. And we find a lot of engineering students, they want to do engineering, but they're really passionate about something else. So it could be that you're passionate about literature, or it could be that you want to craft a degree where you can use your engineering knowledge, but to move more into management. So you might want to combine engineering with commerce. You may be interested in influencing public policy, so global studies would be a good choice there. You may be interested in patent law or something like that, so combining engineering with a Bachelor of Laws. We find a lot of our students are extremely musical. I'm not quite sure why, but I've noticed that over many years here, there seems to be some synergy between studying engineering and being incredibly musical. So we've recently introduced the conjoint with the Bachelor of Music. And we've also got the options with the Bachelor of Property, and with some restrictions, science. You can't do a conjoint with science where what you're studying is the same as you were studying in engineering. So there's just a few restrictions there. But what I'm going to do now is just, I'll play a video which will tell you a little bit about these conjoints. But before I do that, if you registered at the front desk, you will have got a bag, and inside that bag there'll be a document, a prospectus, and that prospectus will talk about the requirements for the conjoint degree. There's one change in the wind which is being approved at present. What we've done is we're slightly extending the number of points you need to do in engineering. So the documentation you've got in your bag will tell you you have to do 405 points of engineering in a conjoint degree, but if we get the approval we're seeking, it will be 420. And all we're doing is we're requiring, if you do a conjoint degree, you do the entire first year of engineering. Previously, we combined a couple of courses, our maths and mechanics course. We've found that put too much stress on the students. It was pulling their grades down. So we've abandoned that, and we're just slightly lengthening the number of points you need to do in your conjoint. So that may apply to you if you come here next year. But I'll play a video now of some students who've actually enrolled in this.
All through high school, I took French and history alongside my sciences and maths, and I really wanted to carry that on. I didn't want to just give it up at university. So studying a conjoint degree, it's really like the best of both worlds. It just balances your study life out, and I've found that I'm enjoying both engineering and arts a lot more because I get the diversity of choosing what I want to study when I want to.
So we'll change tack now, and we'll go back to the main degree, and I'd like to remind you, when I first started presenting this evening, we started talking about what is engineering, and identified three things that really define what an engineer is. They're a problem solver, they're an innovator, and above all, they do things that make a difference to people's lives. We deal with real engineering problems. So somewhere along the way, we have to teach students how to do that, how to deal with open-ended complex problems for which there isn't a single right answer. There isn't an algorithm that diligent rote learning will allow you to unerringly produce the correct answer. So we introduce students to how to deal with these real-life problems through design and also through a set of professional development courses which are required as part of our accreditation requirements, where students are progressively introduced to working in teams and working in open-ended complex problems where there are stakeholders with conflicting requirements, where you can't actually satisfy everyone and where there isn't a single right answer. So I'm not going to talk through all of those, but as examples of what we do, the closure of the Auckland Harbour Bridge, we set up a scenario where a cruise ship came into Auckland Harbour, it lost power. The tugs that went out to get it, something went wrong, they couldn't get it in time and it knocked into the harbour bridge, and it did enough damage that we couldn't actually safely use the bridge, so it had to be closed. It was going to take a year to repair, and the scenario the students were set was, how do you keep Auckland operating throughout that year? And the students were organised into groups actually of 25, multidisciplinary, covering all 9 specialisations in engineering, working on this open-ended problem. And then, since they were in the 4th year for this particular project, about halfway through the project they were thrown a curveball, because that's what actually happens in professional practice. And they were told that a consortium of major engineering consulting companies, international companies, had got together, formed an alliance, and had approached the government and said that they would be able to do the repairs in 6 months rather than a year, provided they had permission to fill in the upper harbour, which would also solve Auckland's housing crisis. So you can see why we did this. We tried to trample over every sensitivity you possibly could, because this is the environment in which our engineers are actually going to operate. They're not going to be operating doing the sorts of problems you'll see in maths and physics textbooks at high school. They're dealing with real complex problems where there are stakeholders with divergent and quite conflicting requirements. And we have to slowly and steadily introduce our students to working in that environment. Another example, which is actually the slide you see behind us, is we set a scenario around the Auckland City Rail Link. So that's the development down at Commercial Bay. It was taken a while ago, it's advanced a bit since then, but if you look very closely, you can actually see the twin rail tunnels just emerging from under the old post office, the current Britomart. This part of the project is a cut and cover tunnelling, but once the tunnel gets up beyond the Sky Tower, it'll be a driven tunnel right through to Mount Eden. So we tend to set projects around topics, current topics that the students can actually see going on around them at the current time. So what do they actually do? What we do is, in year 3, we cancel a couple of days lectures and the students work in groups on an open-ended project. In year 4, we cancel a whole week of lectures in the 2nd semester. And again, they work in interdisciplinary teams. The team size increases from part 1 through to part 4. It's about 25 by the time they get into part 4. And the students work on a very complex, open-ended project, usually worked around something that's going on in Auckland or New Zealand at that particular time. But once again, it's probably best if you hear from our students. So I'll play a video where some of our students describe their experience.
My favorite project will be the airport extension, and there was a group of 10 of us, and all of us came up with different ideas, and the result was just amazing.
This term we got given a systems project was to create a movie. Personally, I hadn't really thought of myself as being very creative, but over the time that we spent creating this movie, creating the whole script, there was a lot that we had to do that involved creativity, which I found quite exciting.
The biggest buzz was on the last night. All the team stayed up till 2 a.m. trying to get it finished, and the next morning we had it printed out, bound, and it looked amazing, and there was just this big buzz.
We're trying to produce engineering graduates who can work globally. To do that, you have to have some experience of other cultures. And one of the ways we do that is at the University of Auckland, we have exchange opportunities. So it's possible for students to take a semester off from here, go to one of our approved partner universities, there's 125 of them in 25 countries, and study there for 1 semester, which is cross-credited against their qualifications here. Now, obviously, we have to be sure that they're studying the right subjects, so they work closely with advisors within our faculty to make sure that there aren't going to be any insurmountable gaps when they come back. You can do that study abroad in the second semester of Part 2, or in either the first or second semesters of Part 3. We don't permit it in Part 4 because it clashes with our Year 4 projects, our research projects, and we don't permit it in first year because we need to use first year to help people transition from high school into appropriate study. Another option, and I'll come to this later in the talk, is that as part of our accreditation, you all have to do 800 hours of practical work so that you get used to working with everyone who makes up the engineering team, from trades through to sub-professional. It's possible to do that engineering work either domestically in New Zealand or overseas, and about 20% of our students choose to do their practical work overseas, so they get the option of also experiencing another culture while they do that. Now, you might think that Central City Campus is going to be extraordinarily boring. Not so. There's actually a vibrant student life on the Central City Campus, and we have a range of student activities available. So the example I've shown here is our Formula SAE team. They build a racing car from scratch. They run this themselves. The students are inducted and managed by a team. There's some staff support. The students raise money for this themselves. They take the car to Australia to race. Over the last few years, we've mostly designed petrol-based vehicles. We've now moved to an electric drive. Our students are involved in a whole range of activities, such as round the bays, party in the park, where's Wally Day? I had to admit, when this was put together, I didn't actually understand that slide, but our team have explained it to us. Our students run an engineering review. They organise this themselves. It's underway at the moment, and they present it. We have a Wakarama team. Our Wakarama team has been very successful over the last few years, and once again, they're going to be representing the university in international competition in Hawaii. We'll be farewelling them in a few weeks' time. So if you think you have to leave Auckland to have fun, no, that's not true. Auckland can be exciting as well. So what I'm going to do now is tell you just a little bit about academic support, and then I'm going to hand off to one of our students to tell you about the Tuakana program, and another of our students to tell you about the WEN program. So one of the fears I had many, many years ago when I came here as a student was I was coming out of a small high school. I was originally from a small town in New Zealand, not from Auckland originally, and I was coming to a very big campus. Well, our campus is much, much bigger now. There's 40,000 students here, about 5,000 staff. We're the size of a small town. Our telephone exchange is bigger than the telephone exchange in Warkworth, for instance. So it's a huge operation that we actually have here. And one of the worries is anonymity. Coming into a class like this, and we have over 1,000 in our first year, so in the course I teach, half of them are crowded into this room and another half are sitting in a similar lecture theatre one floor up, watching me on video overflow on one of these screens. And the worry is, hey, will anyone notice me? Will anyone notice that things aren't working so well for me? Well, actually, yes. There's a lot of help available. We have a student development and engagement team who are mining all of the data we have about you, including how you're accessing our learning management system, how you're doing in your tests and the like, and reaching out to you if they detect any problems. We're acutely aware that the transition from high school to first year can be quite difficult. We're very aware that the first 6 weeks are absolutely crucial. If you settle well in those 6 weeks, you're likely to succeed academically. So we do everything we can to help you, including providing every afternoon of the week mentoring support for Part 1 students, where the mentoring is conducted by Part 2 and Part 3 students. We train them in how to do this, and those mentors are closely connected with the staff who are actually teaching the subjects at that particular time. So if we look at the mentoring team, this is the team here. And at key stages, such as if there's a class test coming up, we supplement that team with teaching assistants, they are postgraduates from the particular course, and also the lecturers from that particular course also are involved in the mentoring at that particular key stage. That team, at the end of each shift, they file a report, and each of the lecturers can read that, so I can see what did and didn't work in my lectures that very day, and I can correct that the next day if I need to. What we also do is we maintain some software called Piazza that some of you may have heard of, where students can post questions and other students can answer them, or the staff can answer them, or some of our teaching assistants can answer. So in the course at stage 1 that I teach, before I came here this evening I checked, we're in our 4th week of lectures here in this semester, and so far there'd been 1,700 contributions on that Piazza from students in the class, and the average response time was 13 minutes. So when a student posted something on Piazza, someone, either a fellow student or one of our instructors, got to that query within 13 minutes. So there's a lot more support available, and we're trying to leverage digital technologies as much as we can to ensure that we do reach out for you and we can identify anyone who's having some difficulties, and we try and get support to them at the appropriate stage. But I do suggest that when you come here, also join into the other activities in the campus. Don't just be one-dimensional in studying. Make sure you join into societies and clubs and so forth, and that we have clear evidence that that's more likely to lead to a successful outcome. So what I'm going to do now is take a small break, and I'm going to pass off to Lupacina Coro, one of our students, to tell you about the Tuakana program.
I put a lot of job into Engineering is about creating change, solving problems and making a difference to the world. And engineers do this using creativity and collaboration, science and mathematics, to shape and create almost every aspect of the world that we live in. And we believe that everyone should be represented in that process. The Faculty of Engineering at the University of Auckland is committed to encouraging more women into engineering and to making sure that their time with us is full of learning, full of inspiration and full of opportunities. We have the Women in Engineering Network, which organises social events and gives opportunities for professional development and networking. We have fantastic lecturers who are dedicated to inspiring our students to pursue their passions. And we have the Women in Engineering Advisor, who supports all of our female students throughout their journey with us and helps them to make change in the world. Let's hear what some of our students have to say about their time with us.
Studying in the Faculty of Engineering is really fun because I think it's a really cohesive faculty. It's really cool seeing how passionate some of the lecturers are about what they're teaching, especially in first year classes, to hear all the experiences and all their own personal research that they bring into their teaching.
They have a great organisation called the Women in Engineering Network, and they're very supportive, so they really value the female students.
I came from an all-girls high school and I'd heard the stories about so many more boys in engineering than girls, but when you sit down in your lecture theatres, it's not a big deal, you just get on with it.
So we've got Michelle Dickinson, Bryony James and Rosalind Archer, who are just really, really brilliant lecturers, and they just inspire me to sort of push more, be better at engineering.
In 5 years I could be working in any number of fields. I could be a researcher, I could be in software, maybe I'll be in consultancy.
We get a lot of exciting projects as well. We had a project in my 4th year where we got to design and test out a little robot that extinguishes miniature fires. So it would detect the fire and it would go along and put it out, and it was so much fun.
So one option you need to be aware of if you're going to study here is that we have a lot of scholarships available, but the closing dates occur very soon. So if you haven't looked at the University of Auckland Scholarships website, please do so. We're going to assemble all of the email addresses of everyone who's given them to us tonight and the other 2 presentations we've made so far in this sequence. And we'll contact you over the next week or so, and we'll actually send you a link to some information so it's easier for you to find this scholarship stuff. But these university-wide scholarships that are on the slide behind, they close fairly soon. So the closing date is the 22nd of August, and you do have to do quite a bit of work to set these up. You'll need to get references from teachers and the like. Some of these scholarships also require that you stay in the halls of residence. The reason for that is, again, when the universities looked at what makes for a successful outcome, in a very big city such as Auckland, long commute distances actually create a lot of problems for academic study. So with these scholarships, or with some of them anyway, there is a requirement to stay in the halls of residence. Those halls of residence started receiving applications on the 1st of August. So if you're intending to apply for one of these scholarships, you should also, in parallel, put in an application for the halls of residence as well. Now, quite apart from the university-wide scholarships, there's a large number of scholarships, over 40, that apply to engineering, ranging from about $1,000 to $7,500. There are a number that apply to first-year students, and again, we'll send you a link offline, which will actually point you toward the scholarships that apply to school leavers in their first year of study here. I draw to your attention this set because, in particular, their closing date occurs at an awkward time. It's about the time where much of New Zealand is shut down for the summer vacation. So the Kickstart scholarships close on the 15th of January. So please do check those out. and just go onto our website, you'll find the details there. This is a picture of some of our scholarship winners. When you complete a University of Auckland engineering degree, you automatically become part of our alumni association, the Auckland University Engineers Association. That's one of the longest lived alumni associations in New Zealand. It was created in 1957, before I was born in fact, and they are a fantastic supporter of this faculty. In particular, they're making a lot of money available to support student scholarships. So check out our scholarships website, have a look also at the AUEA scholarships. They've introduced 2 recently for first year, the AUA Maori and Pacifica Pathway Scholarships. So if you haven't heard of them, do check them out on the scholarships website. Now, career opportunities are obviously of concern to everyone, and particularly to parents who might be worrying about whether engineering is a good choice for their children and whether the expenditure that's involved in studying this degree is actually going to set you up properly for life. Our degrees are internationally accredited via an agreement called the Washington Accord. So if you haven't heard of that, jump on your favourite search engine and check it out. There are currently 19 signatories to that agreement. What that means is that if you complete an engineering degree here, you can go and work in the country of the signatories as, pardon me, as though you had completed a degree in that particular country. So our degrees are very portable in that particular sense. The demand for engineers both domestically and internationally far exceeds the supply. So it's a fantastic career to join. Most people will leave here and go and work in a standard engineering career, such as Penelope. She's an engineering science graduate now working at Fisher & Paykel Healthcare. But the engineering degree equips you to work in other areas as well. If you complete a degree here, you'll finish up with very good quantitative skills, extremely good communication skills, good understanding of how to work within teams and how to communicate persuasively both to a technical and to a non-technical audience. Those skills are required in a whole range of disciplines, so completing a degree in engineering actually opens up a whole range of possibilities that aren't what you might regard as standard engineering careers. Within the faculty, we have a full-time professional staff member, our employment liaison manager, whose job it is to bring to your attention all of these opportunities. So throughout the year, he organises career evenings where employers come in and talk about the opportunities, but it gives you a chance to network and perhaps arrange holiday internship or permanent employment. We have career fairs during the day, and we also maintain a database of employers, 4,500 in fact, who have provided suitable practical work or permanent employment for our students. So we do what we can to make those opportunities available to you, although we can't obviously place you in a particular occupation. You do, as a condition of our accreditation under the Washington Accord, have to complete 800 hours of practical work, ideally during your degree, although some students do complete it afterwards for various reasons. But it works best if you do it during your degree, because then working in industry helps you get a better understanding of why we're doing certain things certain ways in your academic education back here. It gives you a feel for the entire team that makes up the engineering team. You get to work with people in the trades and people in sub-professional engineering as well. That practical work, most students put it together over the summer period, but you can actually do it in smaller sets of hours throughout the year. So there's various options available. You can complete it overseas as well. What we require, though, is that you register the practical work so we can identify whether you are actually working for a company that will give you suitable experience, and we ask you or require you to write a reflective report on your experience of a suitable standard in order to complete the practical work requirement. Now, Auckland's a huge city. Some of you may actually choose, rather than living at home, to actually live in our hostels. So you need to know something about the opportunities that are actually available in the hostels at the University of Auckland.
I chose to live in a hall residence because firstly I'm from Hamilton, so I'm not from Auckland, so I don't have family living here. And I thought it would be a lot easier to transition from living at home to flatting by going to a hall of residence first so that I could get to know the city a bit more before I went flatting by myself.
I chose Uni Hall because I had a lot of recommendations from friends who stayed here the year before. It's less than 5 minutes from the campus, so it's really close if you need to go to the library or to the Commons to study. Living in the city of Auckland is a pretty big change as well for me, coming from a rural area.
Living in a hall in your first year is really important because of all those connections you make and forming that support group around you, especially when you're coming to a new city. If you like to study by yourself, you can study by yourself. But also if you want to study in a group, there's always other people around that you can study with.
Here at the hall we have a well-stocked games room as well as a big screen TV downstairs. In our common rooms we have TVs as well, so we can easily watch movies with the floor, have floor bonding nights.
While I've been at Huia, I've been on the Wakaama volleyball and basketball teams, and all of those events have been really fun. That's another great way to socialise with the people of your hall. You come together as a team and you really bond, which is really nice. You have everyone around you to keep you going. You have the person in your boat that calls, and everyone motivates each other while you're on the water as well. There are a lot of things that are convenient about a hall, such as how close you are to the campus. Huia is about a 10-minute walk from City Campus and 15 to 20 minutes to Auckland City Centre. Everything's just a walking distance away.
Coming from parents who make the best home-cooked meals to mass catering is quite a big change for me, but for feeding 450 kids, they do it really well.
One of the great things about a hall of residence is that you always feel safe, it's secure. It's not just the physical security, but mental security in the way that you have a lot of people around you who can help you if you're needing help, or you can go to one of the RAs and you can always talk to them if you're having any issues with anything.
Staying at Uni Hall is probably the best decision I've made here at the university. You have 450 people that are your age, 30 odd people down your hallway you can easily meet. You just make friends so easily.
So Claire spoke of the Huia residence. It's actually under refurbishment at the moment. So normally we'd have 5 halls of residence. Just at the moment, until Huia is refurbished, we're down to 4. All of the details are on the University of Auckland website. So if that appeals, or alternatively, if you're actually applying for one of the university scholarships for which staying in a hall of residence is a requirement, check out the website for further details. Now there's a number of other opportunities coming up which are going to give you a chance to learn more about what it means to be a professional engineer or what it's like to study at the University of Auckland. And for those of you who are studying in high schools, hopefully by now you will have heard of the Week of Engineering. This is something that's organised by the engineering profession, Engineering New Zealand, where in the main centres, professional engineers will be going out to schools and running activities which give school pupils a deeper understanding of what a professional engineer actually does. But that culminates in an event that's held here at the University of Auckland on Saturday the 18th of August. So if you'd like the opportunity to meet with professional engineers in various practices, come to the University of Auckland on that Saturday. It would be a fantastic opportunity to get just another lens on what the opportunities are if you study engineering. If you'd like some further information about studying at the University of Auckland, we have a Courses and Careers Open Day coming up on Saturday the 25th of August, and all of the faculties will be open on that particular day. And on Thursday the 20th of September for the Women Engineers, Engineer Her Future is on that particular day as well. So a number of my colleagues will be gathered about now down the foyer where you registered to be able to answer any questions that you may have about the particular specialisations. To turn on an event like this is a huge effort, so our marketing and communications team have done a fantastic job to do that. And I also am very grateful to our two speakers. Lupacina's had to leave for another engagement, but Lola is still with us. So would you join me in thanking both our marketing and comms team and our student presenters tonight?